Welcome to the full solution to the practice questions and the second video of scalar product and the vector lessons. In the first question here, we want to determine the coordinates of M, so this point over here, and the angle BMA, which runs from here, goes to here, and then goes here, so that angle over there. And the first part can be done in different ways. That we have done a question like this previously, and what we had done was we would find, the idea was to find a vector AC because we have all the information of the coordinates of the points, and then we can take half of that because we know that these two are the same, so the length of this is half of the whole vector there. And once we find half of that, we will find vector AM. And once we have the vector and we have one of the coordinates, then we can find the other coordinate. So that's method one. But because we have covered that in a previous video, we are going to use a shortcut. Whenever we want to find a midpoint, it's the average of the x, y, and z coordinates. So point M's coordinates are going to be, for the x, is going to be the x coordinate of A and C added and divided by 2. The y coordinate is going to be the coordinates of y from both, so 4 plus 8 divided by 2. And the z components are going to be the z values added and divided by 2. So this is part A. So M, for the first one, 3 plus negative 3 is 0 divided by 2, that's 0. The next one is 8 plus 4, which is 12, divided by 2 is 6. And the last one is negative 1 plus 1, which is 0, divided by 2 is 0. And that is my answer to the first one. For the second part of the question, we are trying to figure out the angle of BMA. So I'll draw that out first. I'm going to connect B and M together. And angle BMA starts from here, goes to here, and goes to here. So we're looking at this angle over here. And if we want that angle, the best vectors to use would be MB and MA. We can take its dot product and then use the dot product to find the angle after. First, we're going to find the two vectors, vector MB, and we want to also find vector MA. So for MB, we're going to use all the x, y, z coordinates of point B, which are 4, negative 1, and 7, and subtract them by M, which we just found. And conveniently, we get a lot of zeros here, which is nice. And I'll do that here. We get 4, negative 1 minus 6 is negative 7, and 7 minus 0 is 7. So those are that is vector MB. And for MA, we're going to use the same concept. Take the x, y, and z coordinates of point A and subtract them by point M. That's 0, 6, 0. And I will get 3. 4 minus 6 is negative 2, and negative 1 minus 0 is negative 1. Now, the dot product of MB and MA would equal to the magnitude of MB times the magnitude of MA multiplied by the cosine of the angle between them. And the angle between MA and MB is this angle over here, and that's why we had to choose MA and MB as our vector. So we couldn't just use BM and AM, for example, because then BM is going this way, AM is going this way, and the angle would be somewhere there. So we need to, if we want to find the angle, we need to make sure that our starting point is shared between the two. In this case, M is the point. So first, for the dot product on the left-hand side, MB, we're going to take the x component of I'm going to just highlight this so you folks can see it. So the x components, I'm going to multiply them, y components and z components, and then I'm going to add them all together. So I'm going to have 4 times 3 plus -7 times -2 plus 7 times -1 on the left-hand side. And for the right-hand side, I will need the magnitude of MB times magnitude of MA times the cosine of the angle between them. I can do everything in the same line here. Usually I do them separate, and I recommend that you can practice both. For MB, my x component squared is 4 squared, my y component squared is -7 squared, and my z component squared is 7 squared. I am multiplying that by root of the magnitude of MA is its x component squared plus y component squared plus the z component squared. And then I have cosine of theta. And just to highlight what corresponds to what, this corresponds to the dot product, or one of the ways to calculate the dot products using the components. MB is this term over here, and MA is this term over here, and cos theta is just cos theta. For the left-hand side, I get 4 times 3, which is 12, plus -7 times -2, which is 14, plus 7 times -1, which is -7, and that equals to the root of 4 squared is 16 plus 49 plus 49, and here I get 3 squared is 9 plus 4 plus 1 cos theta. I'm going to simplify the left-hand side. I will get 19, and that is equal to root of 114, root of 14 cos theta. Divide both sides by root 114 and 14. And this cancels out this, and I'm left with cos theta is equal to 19 over root 114 multiplied by root 14. Putting this on my calculator, I get cosine of theta is approximately 0.47559, and I'm going to use the exact value and take the inverse cosine, and I will get that my angle between MB and MA is approximately 61.6 degrees, and therefore I still have to answer the question, angle BMA is equal to 61.6 degrees approximately. Okay, for the second question, we're expanding and simplifying. So we got 4 times unit vector I minus 3 times unit vector j dotted by 4 unit vector I minus unit vector j. Okay, I am going to multiply by 4I times 4I, and or take the dot product of the two, and then I'm going to take the dot product of going to be plus 4 dot product of I times, or dotted by negative j, and I'm going to add that to, now I'm doing these ones, negative 3j, 4I, forgot the dots, and finally, what do we have? We got this and this, so we got plus negative 3j dotted by negative j. Fantastic. I'm going to start multiplying out the numbers, so we get 16 here, and I dot I is equal to the magnitude of I squared, which is 1 squared. So I'll do it in 2 steps here. So I'll write it like this first, plus then I got 4 times -1, so that's going to be -4. And I have I dot j, and then I have plus, I have -3 times 4, so that's going to be minus 12 j dot I. And then I have -3 times -1, which is plus 3. And then I have j dot j. This is going to be 16I squared minus 4. For vectors I and j, I goes in this direction, j goes in this direction. They're unit vectors in the x and y direction. There's a 90-degree angle between them, and a dot product of I and j therefore is equal to 0, because whenever the angle is 90 degrees, the cosine of angle is 0, and therefore the dot product is 0. So this is going to be 0 minus 12. Unit vector j and I, when we take the dot product, we get 0, just like last time. The angle between them is 90 degrees. And finally, plus 3, same idea as I, it's going to be the magnitude squared. I'm forgetting some equal signs here, so I'm going to put them down. And then I get 16. This is going to be 1 squared minus 4 times 0 is 0, minus 12 times 0 is 0, plus 3 times 1 squared. This is going to be 16 plus nothing here, and then 3 times 1 is 3. So this is going to give me 19 as my final answer. Okay, for the next question, we are given that for unit vectors A and B, so we know the magnitude of these are 1, so we know the magnitude of A is 1 and the magnitude of B is 1 because they're unit vectors, and that's unit vectors by definition have direction, but their magnitude is 1. We don't know what the angle between them is, but we just know their magnitudes are 1. We know that if we were to add the two unit vectors together and take the magnitude of them, we get √3, and we want to determine this expression here. Okay, this is a little bit more challenging question. I like it. Let's kind of get it started. We are going to do this expansion first and see what we can get out of it. So I am going to multiply this by this and then this by this. So I will get 3a and then I will get minus 3 times 3 is 9. I'm just going to do the multiplication right away. And then I will have unit vector A dot by B. And then I will do this multiplied by this. That is -2. And then I have vector B and A. So I'm going to do A, B. Or we know that order doesn't matter when we take dot products, and then we're going to do this multiplied by this, so -2 times -3 is +6, and then we have b dot b. We can simplify this a little bit, so we know that when we take the dot product of two vectors, when they're the same, it becomes the magnitude of that vector squared. And then we're going to have -9 minus 2 is -11 a dot b. And then we're going to have +6, same thing here. We are multiplying the same vector. So, sorry, we're taking the dot product of the same vector, so it becomes magnitude of b squared there. And we know that magnitude of A is 1. So we're going to keep simplifying. Magnitude of B is 1 because it's also a unit vector. That's 3 times 1 squared is 3 plus 6, and that will give us 9 minus 11A dot B. Now, based on all the types of questions that we've done so far, this would be considered a thinking question. It's a little bit more challenging because, yes, we did simplify this and we got this, but we need to somehow, we have the number 9. Number 9 is good, but we have A dot B here, or the dot products of unit vectors A and B, and we got something else here, which is A plus B's magnitude is going to equal to root 3, and we need to make a link to these two. Well, we need to go back to the very basics of how we came up with the dot product in the first place in order to make this connection. I'm going to draw coordinate system here, and in this one I'm going to draw let's say this is unit vector A, it's got a length of 1, and I am going to draw B. Let's say this is unit vector B, it has a magnitude of 1. We don't know the angle between, so I'm going to leave it as theta. And if we were to add vector A and B, what we would get is I would have to take B, take its tail, put it here, and add it to this vector here, vector A. So this is my vector B. And my resultant vector would come from here and go all the way there. And this is vector A plus B. And note that this angle over here is this angle over here. So if I were to expand this a little bit, this angle over here would be theta. And that's because this vector is exactly the same as this vector, and using the F pattern, these two angles must be the same. And if that angle is theta, that means that this angle over here is 180 minus theta, because this is one whole line. This is theta, therefore this side should be 180 minus theta. Okay, so now we know that we have formed a triangle here, and if we were to take the magnitude of this squared, it would equal to the magnitude of this squared plus magnitude of this squared minus 2 times the magnitude of A times the magnitude of B times the cosine of this angle over here. Let's put that down. We got the magnitude of vectors A and sum of A and B squared is equal to magnitude of A squared plus magnitude of B squared minus 2 times the magnitude of A times the magnitude of B times the cosine of the angle between them. But the angle between them isn't theta, it's actually 180 minus theta. So I'm going to put that down here. And this is good now. We're kind of getting a link between this and this. We know that the dot product of A and B is equal to the magnitude of A times the magnitude of B times the cosine of the angle between them. So just theta, but we have 180 minus theta. Well, now we will have to use a property to link cosine of 180 minus theta to theta, and that is cosine of 180 minus theta is equal to the negative cosine of theta. And if you've done your trick, you should be able to come up with this. So I'm going to just do a very brief talk about it. If this angle is theta, that means 180 minus theta would be this angle over here. And theta is, sorry, cosine of theta is always the x-coordinate of this value in a unit circle. So it will be this side over here. And if we took 180 minus theta, it's always negative. The x-coordinate is a negative value, and the x-coordinate of cosine of theta is always a positive value. They will have this exact same length, but they are negative of each other. So because of this, I'm going to write this as a plus b magnitude squared is equal to this minus 2 magnitude of a magnitude of b times negative cosine of theta. Okay, things are starting to work out. We got negative times negative, which is going to make it a positive, and that becomes this whole term there, then becomes the dot product of a and b, which is this, and we can rearrange everything to find that value. So let's do it. We're going to take this set of information from here. We know that this magnitude is equal to root 3, and we need to do root 3 squared. And magnitude of unit vector A is 1. Magnitude of unit vector B is 1. The negative here and here multiplies together to give me positive 2. And I'm going to leave this part the same because I need to link it to this term over here. So now this section over here, we know that the dot product of A and B is equal to the magnitude of A times magnitude of B times cosine of theta. So this becomes A dot B. And we know that root 3 squared is just 3, and that's equal to 1 plus 1 plus 2, A dot B. And then I'm going to subtract both sides by these two ones to get 3 minus 1 is 1 is equal to 2 times the dot product of unit vectors A and B. And then I'm going to divide both sides by 2 to get that the dot product of unit vectors A and B is equal to 1/2. I will then use that idea over here, and I will get this is equal to 9 minus 11 times 1/2. So it becomes 9 minus 11 over 2. That's 18 over 2 minus 11 over 2. And my final answer becomes 7 over 2. I hope that this video gave you some practice with dot products, and thank you for watching.